Hello students, welcome back to our channel Maths by SRAVAN VATAMBEDU. Hope you all doing well, and if you are watching our channel first time, do subscribe to our channel. In this video lecture, we are going to discuss about vector integration. Now we are going to integrate a vector point function. We discussed about differentiation, vector differentiation. Here, integration means nothing. Integration is inverse operation of differentiation. Simply in one word, what we can say about integration? Integration is antiderivative. What I am saying, for example, let f bar of t is a function. F bar of t is a function in a scalar t. In a scalar t. F bar of t is a function in scalar t. Then, if you can assume derivative of f bar of t is capital F bar of t, then what happens? If you integrate, differentiation is antiderivative, so integration differentiation get cancelled. What you will have? Integral capital F bar of t dt is f bar of small t plus c, which is indefinite integration, which don't have limits. An indefinite integration, constant will be added. So this is the vector integration. The integration of a vector point function. We got this one. Integral f bar of t dt is small f bar of t. Like this, we are going to integrate a vector point function. But what is the important application of vector integration? This vector integration is useful to find the application. Application of vector integration is, it is useful to find work done by a force. Work done by a force, which is evaluated using like this: integral over c f bar dot dr bar. So this is the formula to evaluate work done by a force. So in physics we have these concepts, work done. We are generalizing this concept in all the topics. Here, whenever if you want to find work done by a force under a curve, over a curve C, whenever the vector point function f bar is given. This application we can understand in this problem very clearly. So instead of asking that find work done by a force, directly he is asking find integral over c f bar dot dr bar. I said, what is integral over c f bar dot dr bar? Integral over c f bar dot dr bar, we are calling it as work done by a force. Here, integral over c f bar dot dr bar we need to calculate for the given function f bar is 3xy I bar minus y square j bar. Now we are going to evaluate. So here f bar is 3xy I bar minus y square j bar. This r bar is the standard vector which we discussed already. R bar is xi bar plus yj bar. If you take d, what you will get? dxi plus dyj. Now we need f bar dot dr bar. Multiply f bar and dr bar. I dot I1, j dot j1, we know. So if you multiply, what you will get? 3xy dx minus y square dy. But if you want to integrate this one, we need to integrate over the curve y equal to 2x square from these 2 points. If you want to integrate this function, here line integral, one integration, while integrating here with respect to x, this function should be function of x. So complete integral should be in one variable, single variable function. If you have other than x, convert that one in terms of x or convert x in terms of y using given relation. The given relation is y equal to 2x square is given. Now I am going to write wherever I am having y there 2x square, and dy will be differentiation of x square 2x 4x dx. 2 2s are 4 x. Differentiation of x square to x, that's why. Now coming to the limits, because I am converting total integral in terms of x, so I need x limits. From the given points, x coordinate varies from 0 to 1. So limits of x are 0 to 1. Now we are going to evaluate integral over c f bar dot dr bar in the given limits. Integral x equal to 0 to 1. So in f bar dot dr bar, in this I am going to substitute this one in the place of y to x square. 3x, what is y? 2x square dx. What is y again? Y is 2x square whole square. What is dy? 4x dx. Now simplify. Integral x equal to 0 to 1. 3 2s are 6 x cube dx. Or we can write 1 dx. Here also dx we are having. We will take dx common. Now 2x square whole square. What you will get? 2 square is 4. X square whole square is x power 4. 2x square whole square is 4x to the power of 4. Now multiply. 4 4 are 16. X power 4 into x. X power 5 dx. Now integrate, what you will get? Integral x cube. This is the formula to evaluate integral x cube. Integral x power n dx equal to x power n plus 1 by n plus 1. Using that formula, integral x cube. What is integral x cube? X power 4 by 4. X power 3 plus 1 by 3 plus 1. Coming to here, x power 5. What is integral x power 5? X power 6 by 6. So limits from 0 to 1. If you want, you can cancel. 2 2s are 2 3s are 2 3s are 2 8s are. Now write in the place of x1. If you write in the place of x1, what you will get? 3 into 1 3. 3 by 2. 8 into 1 8. 8 by 3. So again take 6 as LCM. 2 3s are 6. 3 3s are 9. 3 3s are 2 8 are 16. So finally, what you will get? Minus 5 by 6. 9 minus 16, minus 7 by 6. Okay, so like this one can easily evaluate integral over c f bar dot dr bar or work done by a force. Work done by a force we can easily evaluate using vector integration. This is very most important application in vector integration. Any doubts you may express. Find work done by a force. Given vector point function is f bar equal to 3x square minus 6yz I bar plus 2y plus 3xz j bar 1 minus 4xyz square k bar. In moving particle from this point to this point along the curves is given. Now we need to find work done by a force. To find work done by a force whenever a vector point function is given, we need to evaluate integral over c f bar dot dr bar. Work done. Work done. We can calculate using this one. Integral over c f bar dot dr bar. As we know how to find f bar dot dr bar, first write f bar. What is given f bar? Vector point function. 3x square minus 6yz into I bar plus 2y plus 3xz into j bar plus 1 minus 4xyz square k bar. This is given f bar. We need to calculate dr bar. Before going to calculate dr bar, what is r bar? R bar is a standard position vector in vectors, which we will take it as xi bar plus yj bar plus zk bar. Now, what is dr bar? So differentiation of x dx I bar plus dy j bar plus dz k bar. This is dr bar. Now we need f bar dot dr bar. If you multiply f bar and dr bar, how we are going to multiply two vectors, that is vector product. How to find product of two vectors? By multiplying these two only. I dot I1, j dot j1, k dot k1. So because I bar dot I bar is 1, j bar dot j bar is 1, k bar dot k bar is 1, we are going to multiply I coefficient with I coefficient, j coefficient with j coefficient, k coefficient with k coefficient. If you multiply like this, I dot j or I dot k will be 0. J dot I 0, k dot j 0. Then what happens? Here we need to multiply I with I only. If you multiply I with j, that becomes 0. I with k 0. J with I 0. So now we are going to multiply I coefficients. 3x square minus 6yz. I dot I1, what you will get? Dx plus j coefficient 2y plus 3xz dy plus 1 minus 4xyz square dz. So this is f bar dot dr bar. The simple thing without writing r bar and dr bar, by seeing f bar itself you can write f bar dot dr bar. The simple technique what I am saying, after doing this all procedure, what you are getting, in the place of I bar you are getting dx in f bar, in the place of j you are getting dy, in the place of k you are getting dz. If you observe this one I, j, k, there what you are getting? Dx, dy, dz. So that is the shortcut without writing r bar, dr bar. Directly you can write f bar dot dr bar. How you can write? Simply in f bar, replace I bar with dx, j bar with dy, k bar with dz. Then directly you will get f bar dot dr bar. Now we need to find integral over c f bar dot dr bar. To find integral over c f bar dot dr bar, what we have to do? We need to evaluate this one using line integral, single integral. Whenever if you use one integral, the total integrand should be in single variable. Either in x, or in y, or in z, or in some other variable which is single variable, not like this. If you are integrating with respect to x, this function should be in terms of x. If you are integrating this one with respect to y, this complete function should be with respect to y. If you are integrating this one with respect to z, you should have complete function in terms of z. For example, here all the terms are x, no need to think about conversion. If here all the terms are in y, no need to think about this relation. If this all function is in terms of z, we can integrate directly x from 0 to 1, y from 0 to 1, z from 0 to 1 by taking that limits. But now the case is not like that. So to convert complete integral f bar dot dr bar in terms of single variable, there is one relation given. What is that relation in between x, y, z? X equal to t, y equal to t square, z equal to t cube. Now wherever you are having x in f bar dot dr bar, there you are going to write t. Wherever you are having y, there you are going to replace y with t square and z with t cube. Now what about dx? Dx is dt, differentiation of x dx, differentiation of t dt. Like that, differentiation of y dy, differentiation of t square 2t dt. Differentiation, in differentiation, exponent decreases. If you have 2, you will get 1. While integrating, exponent will be increased. 2 becomes 3. Because in this, we will have differentiation and integration. Don't confuse. Integration increases, one small technique. Differentiation decreases power. So coming to here, differentiation of z dz, because differentiation, power will be decreased. So 3t square. The formula used in differentiation is differentiation of x power n into x power n minus 1, 3 into t power 3 minus 1. So these things we are going to do in f bar dot dr bar. Okay, we will replace x with t, y with this one, z with this one, dx with dt. What about t limits? Here very clearly given x equal to t. So x limits will be t limits because both are equal. So here x limits we will get here, x is from 0 to 1, y is from 0 to 1, z is from 0 to 1. So t limits of t will be limits of t 0 to 1. So now I am going to evaluate integral over c f bar dot dr bar by replacing these all in f bar dot dr bar. Integral t equal to 0 to 1. 3. What is x? T. Write in the place of x t. 3t square minus 6 into what is y? T square. What is z? T cube. Dx. Dx is dt. Plus. Here, write in the place of y t square. 2t square plus 3 into, write in the place of x t. T. Write in the place of z t cube. T cube. Into dy. What is dy? 2t dt. 2t dt. Plus, coming to here, 1 minus 4, x is t, t, y is t square into t square, z is t cube whole square into dz. Dz is 3t square dt. 3t square dt. Now we need to simplify very carefully to get work done by a force. So that equal to integral t equal to 0 to 1. 3t square. Here we will have 3t square minus 6t square into t cube. T square into t cube is t power 5. 6 t power 5. So coming to the next one, dt I am going to write at the end. Dt will be common. Dt at the end we are going to write. Coming to here, 2 2s are 4. T square into t, t cube. 4t cube. Now coming to here. Next one. 3 2s are 6. 3 2s are 6. T into t cube. T power 4 into t. T power 4 into t. T power 5. Coming to here. Multiply with this. 1 into this one. 3t square. Coming to here. 4 t. 4 3s are 12. Okay. Coming to here, t square, t cube whole square. T cube whole square. A power m whole power n. A power mn. 3 2s are 6. So here you are having t power 6. Bases are equal. We will add exponents. 2 plus 2. Here power plus 1. Here power plus 2. So 6, 2, 8, 9 plus 2, 11. Now multiplying with this term with this, 3 4s are 12, plus into minus, minus 12. If you add, base are equal, if you add all powers, 2 3s are 6, 8, 9 plus 2, 11. T power 11 dt. Now coming to the simplification part, t equal to 0 to 1. First I am writing t square terms. 3t square, 3t square. So totally 6t square. T cube term only 1. 4t cube. So 6t power 5 plus 6t power 5 minus 6t power 5 get cancelled. Now The leftover term only one, that is minus 12 t power 11 dt. Now integrate, as I said, integration increases the power. So integral t square t cube by 3, integral t cube t power 4 by 4, integral t power 11, 11 plus 1 12, t power 12 by 12 from limits t equal to 0 to 1. So 3 1s are 3 2s are 4 4 cancel, 12 12 cancel. What is left over? 2 plus 1 minus 1. Plus 1 minus 1 get cancelled. Answer is 2. Any doubts you may express.